Hello, welcome to the podcast How We Build, talks about civil engineering in a different way. My guest today is Rohan Singh Wilkho. Rohan is a Schmidt AI in Science Postdoctoral Fellow at Cornell University. Holding a PhD in civil engineering and Master of Science in computer science from Texas A&M University, he works at the intersection of physical infrastructure and digital intelligence. Rohan develops cognitive civil systems, that is infrastructure designed to perceive and adapt to its environment like a living organism. He applies AI-driven methods to surface critical behavioral and distress patterns in infrastructure networks, ensuring they remain resilient in an unpredictable world. Hi, Rohan, and welcome to the podcast.
Thank you, Navina. It's a pleasure to be here. I was listening to your previous episodes with Andres and Mark, and it really resonated with me because uh, in your podcast you have been treating engineering as a human story and not just as a technical one, and that is exactly how I approach my work. So I think it's going to be a fun conversation.
Thank you very much. It's really great to have you here today with me. Um, let's start maybe with the first question, or actually introduction to our topic today. And if you can say a few words, what are cognitive systems? And I put it in parentheses, cognitive engineering, if we can relate between those two. And how do they apply to civil engineering?
So, I think the best way to look at cognitive systems or cognitive engineering is to think of a city like a human body. A human body has three layers. There is a skeleton which carries the weight to hold it up. The human body has senses to feel the world, take in the information, and it has a brain to make decisions. Right now, in civil engineering, we have built a magnificent skeleton. We have the roads, the bridges, the dams. They are strong, they carry weight, but oftentimes they are passive. Take the US road network, for example. The local agencies in the US, they own, operate, and manage around 70% of the US road network. But they often lack the resources that are necessary to inspect these roads constantly. So they are forced to be reactive because of these constraints. They wait for a complaint, or worse, they wait for an accident before they fix anything. Now, that is an agency without a nervous system. Imagine if we give that agency a cognitive system. Suddenly, the dynamic flips. What I mean by that is that it will happen in three stages. The first is perception. Instead of expensive manual crews, the agency could use something like satellite images and AI to see and detect the defects automatically. The second stage is reasoning, where it just doesn't hand a list of potholes to the agency, but it looks at the current budget, the future traffic, the future weather, and all the information, and compiles them to give a list of critical roads in the present and the near future. And the third is action, where it suggests the exact maintenance plan to improve the network's health. So it is an end-to-end system where it can perceive, reason, and act. So coming back to your original question, what is a cognitive system and how it applies to civil engineering? I look at cognitive systems as a framework that adds a brain and a nervous system to the skeleton of our infrastructure. It takes a system that is passive and reactive and makes it active and adaptive.
Thank you. That is really interesting. So my view or my question here is that this is something as going beyond the digital world. This is going now into use of that data in an engineering way.
Yes, precisely. We already have a lot of information available to us. But with the technology advancing at the pace that it is only important that we make use of that information. To give another example, Let us consider that we have an urban area where there are a lot of roads, and we have a digital twin of the network, of the road network, available live to us. We have the live traffic and everything. On top of that, in the digital layer, digital twin, we have a layer for the precipitation. Let's assume the precipitation that's going to take place in that urban area. Now, if we are able to use that information smartly so as to be able to accurately predict if, say, suppose there is going to be a flood in the near future with sufficient lag time, we can take preemptive measures and close off sections of roads which are more likely to be flooded before the flood happens. So it is not just, as you mentioned, it is not just having or digitalizing that network, but making use of the information in that digital network. That is how I look at cognitive civil systems.
But the cognitive civil systems will be able to make that use of the information on their own.
So they will, of course, need a human foresight. So the way I look at it, I do not look at them as autonomous systems, but but giving them those systems the tools so that they have more agency, so that humans have more agency to make the decision to make the infrastructure safe for our communities.
I'm preparing for this episode. I was looking into dictionary because I like to start with the some word is described in the dictionary. What is the meaning? So I was looking into cognitive and cognition, and there is this component or s- psychology because it is something that is researched mainly in maybe more social sciences or life
Mhm.
sciences, right? So how do you see this cognitive as the as a term used in other life sciences? How do you see it fits with this technical discipline?
This brings me to another point where, uh, like in the current academic world, I am experiencing that that even the boundaries between different disciplines is dissolving. So there has been more interdisciplinary research. I have written papers with people who are working in the Department of Geography, Department of Public Health, and all of that. So with that interdisciplinary approach, with those the boundaries dissolving, uh, I feel it is the time is very opportune for us to be able to uh, be inspired from what's happening in some other field or what some other fields have been using. So like as the definition of cognitive is, like it relates to a process of acquiring knowledge and understanding through thought, experiences, or senses. So for infrastructure, when it comes to infrastructure, I look at the thought and experience is of the civil engineer or the researcher or the entrepreneur, and the senses are the sensory information that we get from our digital twins or the different sensors or data that we have on our infrastructure systems. So that is where I see the human component as well as I don't like talking about it as the digital component, but for the lack of a better word, the human component and the digital work component complement each other so that we are able to make our infrastructures more resilient to rising global demands, and also make our communities who live within those infrastructure more safe.
Thank you. I think then that is we maybe touched upon a little bit already on the second topic or second question about where cognitive civil systems are taking us.
You know, whenever we like somebody asks me a question about where these systems are taking us in the future, more often than not, people are looking for answers or very sci-fi answer They start visualizing things like multi-million-dollar drones flying on every street corner and everything. But I think we are actually moving in the opposite direction. We aren't moving towards complexity. We are instead moving towards what we can term as frugal innovation. Right now, what we have in our society is a massive divide. Major cities like New York or London, they can afford to be smart. They buy LiDAR trucks and expensive monitoring. But what about a small rural town in Texas or a village in India? They do not have the resources. They are essentially flying blind. So, where this technology takes us, I think it is taking us to a place where safety is no longer a luxury. Like one of the works or the research work that I have been involved in is a software tool called Roadlands. Now, instead of forcing a small town to buy a $500,000 inspection truck, we simply use the satellite imagery that we already have and AI to turn those standard pictures into high precision diagnostic tools. Now, suddenly, the small town has the same eyes as the big metropolis. So that is what I mean. To me, the future is not just about building better systems. It is more about building better and wider systems. It's about democratizing the infrastructure and ensuring that every community gets the same care and the same right to safety.
Thank you. This is really interesting perspective and surely something that becomes viable today with all these technologies and but also requires careful planning and development in that direction. And as I said, it is really there is a gap between the capacities within the smaller communities to deal with these complex engineering problems versus big communities or wealthy communities that they can afford either to buy services or have already that kind of knowledge within those communities. So if we can maybe just now change a little bit perspective here, because you mentioned there is a human component in this um, civil systems or civil engineering systems. But how cognitive civil systems apply to everyday work of civil engineers, and if we can maybe mention some examples.
Hmm. So that's a very interesting question because this question reminds me of a LinkedIn quote or a LinkedIn post that I read a couple of days ago. It was from an artist who said that I do not want the AI to do the art for me, but I want the AI to cook and do the dishes for me so that I can focus on the art. So that is what I feel these systems will empower civil engineers on a daily basis to like critically think about problems. It will fuel their creativity and it will lead us to a space where we are able to fully utilize the cognitive part of our brains as well, rather than doing mundane tasks. So, if I have to give an example, I'll give an example from my own experience as a site engineer. Before I started my PhD, I was an execution engineer in an underground tunnel project, and my main responsibility was to stabilize the soil around the cross passages. Cross passages are passages between the twin tunnels for safety spots for passengers when the tunnels are in use. So before we start like boring between the two tunnels, we had to inject some sort of a cement slurry to stabilize the soil in the region. And now, while we were stabilizing the or injecting the cement slurry and stabilizing the soil, we had to be cautious about two things. One, that the pressure of injection is not too high to damage the tunnel rings on either side. And second, the pressure is not too high, so such as to be um, to cause the soil or the ground above to crack. Whereas I also had to ensure that the pressure is not too little, such that the soil would collapse once the boring starts. So there was a mechanism to that we had developed for monitoring on a daily basis. Like we had an instrumentation team who used to come every 12 hours to inspect if there has been any deflection in the tunnels, and also if there has been any ground settlement or anything of that sort. But the critical part of this was the instrument team was used to come once in a shift, like once every 12 hours. But the soil stabilization activity was a continuous task. It was going 24 hours nonstop. So I had to cautiously wait for 12 hours to receive the report, whether the tunnel has deflected or not, to be assured that the injection pressure that I have on my soil stabilization is correct. A critical part of this was also that we had unknown soil strata. Like, even despite we had detailed geotechnical reports, but every cross section of the tunnel was not geotechnically investigated. So we essentially had no idea, like very little idea about the kind of soil that we're trying to stabilize. Now, here, if I had an access to a cognitive system, like if I had access to sensors which had the ability to continuously read uh, read the information available. The information can be the tunnel deflection, or it can be the pressure that my instrument is facing when we are injecting cement slurry into the soil. Now, if such a system would have existed, it could have given me a live report of the tunnel deflection, and also a live report of the stiffness of the soil that I'm about to stabilize. Now, with the information that I might have had about the stiffness of the soil, it allows me to get into the real engineering now. Now, I can use my critical thinking to adjust the pressure of the injection. I can use this information to adjust the consistency of the cement slurry that I am injecting in the soil. So rather than worrying about if I am doing it right or wrong, with this information available, I am able to not only free myself and my team of the constant worry that if we are doing something is right or wrong, but it also gives us actionable information. And the result of it is we just don't stay safe, we move faster, and the entire project timeline shrinks. So this is how I exactly see these systems, what these systems do for us. They they do the so-called dishes, that is the monitoring, the data curation, and all of that, or data crunching and all of that, so that we as engineers, we can focus on the art. We can focus on solving problems creatively. So that is how I look at such systems aiding civil engineers on a daily basis.
Thank you. This is really nice example, and as you were saying, as you were talking and explaining, I was just imagining how it looks to go every 12 hours, and I believe that many colleagues can relate to those kind of situations when you just need to be physically present, actually at the spot to see and to decide as an engineer on the actions. But I also see, I mean, through these examples, that this helps civil engineers to overcome, firstly, like spatial problem or constraint, like being at one spot and just having information from points of your project, because it's not always feasible to have a scanning of everything that you're doing, and that you're using, I mean, samples to determine the stiffness or strength or whatever. But like with this and with the sensors technologies and the digital tools, this can be resolved. So one is the space, like you can observe and digest more through one observation instead of being at one spot. That is one, and the other is, as you said, time.
Mm-hmm.
Time as I wouldn't say it's not not constrained, but more element that we cannot control, right?
Control.
It's it's there. We are adapting to it by our actions, but with this, we can use it for more critical thinking and the things that we as an engineers can contribute and work on.
Like this also reminds me of I think the first episode of your podcast where Mark was talking about systems level thinking. So having that coverage of the entire like the entire project rather than just your specific task, like you were mentioning, that also triggers system level thinking. Like we are able to think of outcomes and not output.
There a perspective when we can think that not just complement the skills or the knowledge, but also maybe take part in some decision making or responsibilities share or things like, I mean, other parts which are not complementary only, but are there other perspectives or components that we should maybe think about or discuss more or be aware?
Yes, like again, this takes me back to my days as a site engineer when I was working in that project. Uh, the engineer who used to work at the tunnel site used to be only concerned or thinking about the tunnel. The engineer who was working on the stations, the metro stations, that engineer used to work only on the metro stations. So there is also a lack of coordination. There was, in fact, a lack of, not necessarily a lack of, but I believe the coordination between these even the site engineers at different sites for the same project could be improved. So, uh, coming back to the question, what additional considerations uh, like a civil engineer could keep in mind when they are in the field is like how their work is complementing the other works of the same project. Like if you're building a tunnel, also keep in mind uh, what the site engineer who's building the station is doing. Like how can we best work together so that the outcome is met. And the other part is also like this was just for the site engineers, but uh, when we also talk about, there are other departments in the project. We had a planning department, we had a design department, we had a quality department. Also the, I believe the communication and the bird's eye view of the project. Like, in short, I feel having a bird's eye view of the project, like what are the different moving parts of the project and why each moving part is important. I feel a knowledge of that or an appreciation for that will aid a civil engineer in performing their job. And how this ties to the cognitive civil systems is like, as you were mentioning, it is something very similar to, as you were mentioning, like if we are able to show children or students in classrooms some sort of examples of the digitalization of the physical assets, it is it becomes easier for them to be able to learn and understand how the world is functioning. Similarly, if we have a bird's eye view of the entire project and all the engineers involved or all the key personnel involved in the project can visit or can view that bird's eye image, that will help them establish better coordination between the departments, various departments of the project, and also give them the purpose of that they're building something big than what they are working on, and they have a bigger purpose. So I feel this is also what such systems will enable in the future.
Yes, thank you. This is really interesting. Somehow, from our conversation, I'm getting more the infrastructure and objects are becoming integral part of decision making. Infrastructure is also becoming alive and actively by providing
Yes.
information about itself. actively participating actually in any kind of decision making? Is it engineering or other kinds of this is something how I get as from our conversation.
Precisely. And you caught it beautifully. Like the whole premise of it is basically that our infrastructures are also living things. So like as humans age, infrastructure also ages, just to draw an anomaly. And so therefore it's time that we start treating our infrastructure as living systems, and be and make and be like maybe be more empathetic towards them, and also ensure that our infrastructure is also more empathetic towards the people who live in them.
So now to discuss future as a colleagues, civil engineers. So what is your view on what the future civil engineer might look like in, let's say, 10 years from now?
I remember when I was graduating from my undergraduate college, I was trying to find a job in a general contracting firm and everything, and uh, there was always divide or a gap between the academic knowledge that we have gained in the universities versus the skills that uh, these companies were requiring from new or fresh engineers. So that led me to think like, and the way that engineering is being taught, like in most parts of the world, uh, now civil engineering in itself, it has been there for with us since the pyramids and before that, and it has very like, and even today we do not know how the pyramids were built, so we do not know everything about civil engineering. So one thing that I look the future civil engineer as is first that the knowledge that they gain through universities or through whatever medium that exists 10 years down the line, is that they think of that knowledge as not the holistic knowledge of civil engineering, but just as the sufficient knowledge that is required to be able to learn new things as they go. So the one thing I look as at a future civil engineer is they're more flexible in their approach, as most of us are right now. And the second thing that I look when I look into the future, I think about civil engineers is currently we have very siloed definitions of career trajectory that a civil engineer can take. A civil engineer can either be a site engineer, a civil engineer can either be a researcher or an academic, or a civil engineer can be an entrepreneur. So far, being in that silo has been okay, and people have achieved great success being in those silos. But I feel we are moving towards a place where the boundaries between these three silos is dissolving. And so, in the future, regardless of the job title that one civil engineer might have, like civil engineer can be still a site manager or a professor, I think we will still, each civil engineer will need to have three distinct souls in their body. They'll need to understand things from a site engineer perspective, like understand the physical reality of mud and concrete. They will need to understand how a researcher thinks, like instead of just going blindly and building things, they need to ask critical questions. They will need to ask critical questions as to why are they building this, and does this actually solve the problem and give us the outcome. And the third is they will also need to have the vision of the entrepreneur, and where they need to see the promise beyond what they're just currently doing, so as to be able to add long term value to the project, and bring that long term value to the community. So I feel the future is not just about choosing one path, it is about synthesis of the different souls of civil engineers. And just like the cognitive systems that we were talking about, I feel the civil engineer of the future must stop being rigid and static. To survive, we must become active and adaptive. I believe some of your listeners might be students, and I was a teaching assistant for a couple of years, and then I taught a full-fledged course in my university a while back. And what I bring this point up because I like teaching, and students are close to my heart. So I believe the only thing that I would like to share with those students is to keep their minds open. Like I used to tell my students, like I used to teach a course on surveying, and I used to tell them that my job is not to teach you everything about surveying. My job is to give you information and knowledge which is sufficient so that you can go ahead and gain more knowledge much more easily about surveying, for example. So I would so that they're more so that my students are more flexible and they keep an open mind. So this is just a take home point that I would like to give to your student researchers is whatever you learn in the university, learn it, but keep an open mind. Like the world is much bigger than outside, and the job of your professors is to make you capable of learning more. I have been listening to the podcast, and you have been asking your guests how they look at civil engineering in the future. How do you look at civil engineering in the future?
Yes, thank you for that. The way I see it, I see these two worlds. And I think this is something that is emerging from from various conversations. So there is this physical component of our profession, and it will still be there and remain. So we will still need to learn about physical parts of what we are doing and what we are building, and that is something that will stay, will not change. Maybe it will change how we teach or how we learn. Because with, as you were saying about cognitive systems, and I was just thinking, actually crossed my mind that it is a powerful tool also to be used in education and to give students possibility to experience real world examples from the classroom, because
Mhm.
they can then sense and feel how the things are developing, how the real information from the physical asset looks on the screen and what does it mean and all these things. So I think it can really help in bringing those skills up. That is the physical part, but also there is this um, other part which is linked with the physical, but I don't want to say digital. It's not only digital. Is this a role as a civil engineers, and that we should, beside this physical component, also have this sense of impact that we have on the society's environment, not only, I mean, environment as a natural environment, but the environment in general, communities and everything else. We are adapting to new technologies. As in engineers, we are more aware of the role that we have in the society. If we can maybe go to a closing reflection and just to, if can ask you to finish the sentence, how we build.
Yeah, so I've been listening to your podcasts, and I really like that you have asked asked your guests this question at the end to be able to reflect and complete the sentence how we build. And I also like the name of the podcast. So I feel how we build uh, right now and more importantly in the future is by giving our infrastructure the intelligence to be able to perceive the changing world and the empathy to protect the communities that live in it.
Thank you. Thank you for listening. I invite you to share your views, suggest topics, and recommend guests. And now, over to you.